Welcome to 3.1 Weighted Circuits Notes and Practice. This is Unit 3 of 4 for your at-home learning discrete math units. Let's get started. So, the weighted circuits is all about the traveling salesman problem. What is the best path to travel? So now that you know what Hamilton paths, Hamilton circuits, and complete graphs are, we're going to solve some traveling salesman problems. We're going to be finding the lowest cost to travel. So here we have a graph of 5 cities, A, B, C, D, and E, that our salesman, Willie Loman, right over here, must travel. And notice that even though it looks weird, this is a K5 complete graph. The weight of an edge is the cost to travel that edge. So let's find the weight of edge AB. Well, that's right here, and that is $185 to travel from A to B. How about EB? Here's E and B, and if you look, it's actually this one down here. It's going to cost $200 to travel from E to B. Okay. Next, we want to find a Hamilton path that starts at A and ends at D. Now, as you should know from Unit 2, there's a lot of different Hamilton paths that you can travel. I chose to go from A to B, which is $185, to E, which is $200, to C, which is $120, then to D for $174. And I've traveled every vertex. To then get the final cost, I'm going to add those numbers together. 185 plus 200 plus 120 plus 174. And I find that this trip is going to cost me $679. Now, can you find a different path from A to B with a different weight? Comment below and let me know what you got. Okay. Now we want to find a Hamilton circuit that starts with edge CD. Well, here I started with AB. So let's erase it and start over. Now again, CD, there's not just one. However, I'm going to start from C to D for 174, and then I'll go to A for 152, and then I'm going to go to, let's see, B for 185, and then E for 200. And if I was doing a path, I would stop, but I'm not. I'm doing a circuit because Willie needs to get home. He needs to get back where he started, which for us in this one was C for 120. I'll then take those numbers and I'll add them up. 174 plus 152 plus 185 plus 200 plus 120. And I find that that journey will cost me cost Willie $831. All right, next, I need a Hamilton circuit that is going to end with EA, meaning E to A is my last leg of my trip. So I have to start at A, and E has to be the last vertex that I go to before I go back home. So I chose to go from A to B for 185, B to C for 121, C to D for 174, D to E for 199, and then E to A for 133. Adding those up, 185 plus 121 plus 174 plus 199 plus 133 is $812. Now, remember that when we are looking at a graph model of a traveling salesman problem, our sites, or the places that we're traveling to, are the vertices of our graph. The costs are the weights of the edges. A tour is a Hamilton circuit, and an optimal tour is the Hamilton circuit of least total cost. And during this unit, we're going to look at 3 different methods for finding an optimal tour. Okay, let's do a few practice problems. All right. For each of the graphs listed below, find a Hamilton path and a Hamilton circuit that start at the same point but are not the same. All right, there are some suggested circuits and paths in the answer key. I believe it is 3.5. I'm just going to see what I find here. I'm going to go A, D, B, C for my path. So my path is going to be A to D to B to C. And that is 143 plus 103 plus 76. 143 plus 103 plus 76 is 322. That's my path. Now let's find a circuit, and it needs to be a different circuit. Let's see. I'm going to go A, actually, A, C, D, B, A. All right. So my circuit, I'm going to abbreviate that C, is going to be A, C, D, B, A, which is going to be 89 plus 112 plus 103 plus 94. Let's see what that gets us. 89 plus 112 plus 103 plus 94 is 398 to travel that circuit. All right, graph B. I need a path. I'll go A, B, C, D, E. Easy enough. My path will be A, B, C, D, E. And that's going to be 47 plus 18 plus 62. Yes. Plus 56. All right. 47 plus 18 plus 62 plus 56. 183. That's my path. So now I need to find a different circuit. So I'm going to go from A to D to B to C to E to A. So here, my circuit, A, D, B, C, E, A. And that's going to be A to D is 65, D to B is 84, that's an expensive trip. B to C is 18, C to E is 38, and E to A is 73. 65 plus 84 plus 18 plus 38 plus 73. This trip will cost me 278. All right, last one. For my path, I'm going to stick to the path of least resistance, and I'm going to go A, B, C, D, E, F. So my path, A, B, C, D, E, F. A to B is 18, B to C is 17, C to D is 13, D to E is 17, and E to F is 16. So 18 plus 17 plus 13 plus 17 plus 16 is 81. Now, I need a circuit that's different. I'll go A, C, E, F, D, B, A. And remember, once again, this is not the only path. This is not the only circuit that you can take. It's a K6 complete graph. If you remember to do 6 minus 1 factorial, then you realize that there's 120 Hamilton circuits in this thing. Just looking for one. Okay. So this is my circuit, and I went A, C, E, F, D, B, A. A to C is 15, C to E is 23, E to F is 16, F to D is 24, D to B is 19, and B to A is 18. So adding those together, 15 plus 23 plus 16 plus 24 plus 19 plus 18 is 115. All right. Good job, guys. I'll see y'all next time for 3.2. Have a good one.